Again, I'm recording over one of my own videos. Okay, this time we're given an infinite sum. Limit n approaches infinity, I equal 1 to n of 4 times 5 over n. Well, the key is to always work with the definition. If you write down, and we're asked to find the definite integral. So if we write down the general case, we can always come and just match to get the specific case. So I need to start with my definition. I need to start by writing down the definition of the definite integral. Okay, so the definition, as the definite integral goes from a to b of f of x dx. Okay, again, f of x is the height, dx is the width along the x-axis. That's equal to the limit as n goes to infinity. Now I need two counters here, an I and an n, because n's keeping track of that infinity for me. I equal 1 to n of f of x sub I. X sub I stands for each x we're using, right? For every darned one of those infinite number of rectangles, right? So f of x sub I times delta x. Okay, and that delta x is again the width of each rectangle. Okay, we're assuming them all to be the same. So f of x sub I is my height, delta x is my width. There we go. Okay, now we just need to come down here and match. Well, even before that, we need to for sure say what delta x is. In general, delta x is always b minus a over n. Okay, so our upper bound minus our lower bound divided by n, which are infinite, and we're approaching infinity here. Okay, so x sub I is in general a. We have to start evaluating at a, assuming like a left Riemann sum, right? And then plus I times our delta x. So I times the width of each rectangle. Okay, so those are absolutely crucial for us to start. Okay, so we're first going to look for our delta x, our width, and we see that it's 5 over n. Okay, so that means b minus a must be 5. So I know my definite integral is going to have a width of 5. Okay, now the next thing I look for is my I, because that tells me something about the a plus I delta x has got to get substituted wherever there was an x in the original function. But here there is no I. So that tells me there was no x in the original function. So I must just have the constant function here. And in this case, we can see the constant function would be 4. Okay, I know that for sure because I don't have an I in my sum here. So I must just have the constant function 4. So this must be the integral. The width is 5, so 0 to 5. Constant function is just 4. And then, of course, the width dx, when we're using integral notation. Okay, so this is the same thing, just written in definite integral notation for you. Hope that helps.